we'll do is once we will revisit our concepts of randomization. So once we will brush up them and we will start with our constraints. Okay, so let me share my screen. Yeah, hope my screen is also visible, right? Yes. So so this is what we have started in our previous sessions. We have started with our concept of randomization. What is this? Yeah, we have started with the concept of randomization and we have seen about the keywords. Rand keyword we have seen and rand c keyword we have seen. So one is rand keyword and another is rand c we have seen. Next, we have also seen that there will be two functions. One is pre-randomize and post-randomize. Pre-randomize is going to call is going to be called before the randomization is going to happen, and post-randomize is going to called after the randomization is going to happen. And after that, we have seen that this randomize function, if we are going to call, it is going to return you either one or zero. Next, we have seen about the constraints, and constraints is nothing but it's a condition, and this is how we are going to declare our constraint, right? And so just we are going to write down a constraint followed by constraint name and the condition we are going to have. Okay, and we have seen in our previous session we have seen the two cases where in the case one where parent and child are having two different constraints, and what is going to happen is these two constraints are going to work. Okay, this is nothing but constraint inheritance. Okay, and the case two, what we have seen is parent and child are having the same constraint name. So this is known as constraint overriding. Okay, and the second constraint is being executed. Okay, so this cases, two cases we have seen, and we have also discussed about the rand underscore mode. So what was happening if we are going to use this rand underscore mode, we are turning off the randomization. Okay, randomization was not being performed. Okay, so till that particular point we have discussed in our previous sessions. Okay, now in this particular session, let's start with the new topic, which is constraint underscore mode. So like same like our rand underscore mode, we are going to have something known as constraint underscore mode. Now, if this is equal to zero, then what is going to happen is we are going to turn off the constraint, and if it is equal to one, we are going to turn on the constraint. Okay. So let's say suppose some handle name dot constraint underscore mode of zero, then what is going to happen? You're going to basically turn off the constraint, right? And let's say if you're going to write down constraint underscore mode of 1, then you're going to turn on the constraint. Depending upon your writing, you're going to basically turn on or turn off the constraint. Okay. So this is how you're going to write it down. Okay. That also will once check it out what is going to happen. Okay. Let's first of all, let me open this tool. So let me declare a module, and here I'm going to write down simple class and constraint C1. Okay. Here, let me declare one variable also. Let's say int a. And here what I'm going to write down is a is greater than 50 is the constraint which I've declared over here. Okay. And followed by end class. Now within an initial beginning block, what I'm going to do is I'm going to declare a class handle, let's say T1. And for this, I'm going to create an object and I'm going to randomize it. T1 dot randomize. And I'm going to display $display t1 dot a is equal to percentage d comma t1 dot a and followed by end and end model. So this is what I've written over here. And let's check it out what is that I'm going to have. So value of a which is greater than 50, that will be displayed, right? So t1 dot, okay, what happened? Randomization failed. Condition of randomization called. Okay, sorry. Yeah. So let me call it again. Yeah, so it is basically declaring that thing, right? Now let me write it down. T1 dot constraint underscore mode of 0. Okay. And let's check it out what is going to happen. If I'm going to turn off the constraint, what happened over here? T1 dot. Okay. Actually, I need to turn off it whenever before going to call the randomization method. Let's check it out. So see, so I'm whatever the constraint I've given that is not working. So the value which is less than 50 is being displayed. Okay, is it clear? So this is how your constraint underscore mode is going to work. Any doubts or any queries? So constraint underscore mode is going to enable or disable the constraint which you're going to have. Okay. Yeah. What happens if we declare soft in both the class and if there are two properties in the class and we want randomize only one property? Okay. Uh, any other queries? Up to here, is it clear? Okay. Now, so first of all, let's see the soft keyword. Let me declare one more class over here. And this is test2. And let's say, let me discard this variable and is less than 50. And let me write down the soft keyword over here. And here also, if I'm going to write down the soft keyword, and let me declare one more handle. This extends from T1. Okay. And sorry, not T1, it's test. And let me declare the second handle test2 T2. T2 is equal to, yeah. So what is happening over here? A is greater than 50 is being executed. Okay. Let me call it the randomize method with my child handle and let me run it. So basically T1 dot A is it is displaying as 0. Let me run it for a few times. Let's say repeat of 4 begin and end. So I'm getting 0 itself. So if I'm going to use soft keyword with both the variable, both the constraints, I'm getting the value of A that is being displayed is 0. Okay, GPT. I think so. I'm not confident about your answer. What is happening? Because generally we use soft keyword with the parent variable, but I haven't used this soft keyword with both. So this is the first time I'm trying. Yes, Amar. So basically, we have started in our previous sessions. We have started with randomization, and we have also started with the constraints, and we have seen about constraint inheritance and constraints overriding. We have seen. Okay. So that particular playlist you can watch it in the group also. The playlist has been posted. Okay. Yes. So this is about your constraint inheritance and constraint overriding and constraint what to say constraint underscore mode. Now let's say if you're going to turn off the constraint using T1 handle, that is one class handle, and if you're going to randomize using the second class handle, what is that you're going to have? Let's say is greater than 50 and is less than 100. This is what I'm going to give. Okay, so this is the second constraint and this is the first constraint which I have given. And I'm turning off the constraint using T1 handle, but I'm performing the randomization using the T2 handle. What is that I'm going to have? Whether the constraint present in the T2 class handle will be discarded? Yes or no? Whether the constraint which is present inside my T2 class handle will be compromised? Yes or no? No, it is not going to be compromised. Let me show you. So previously also I've shown you, right, the randomize with the randomize underscore mode, rand underscore mode. So what is happening over here? Okay, let me remove the soft keyword. Let me save it and run it. What happened? A is greater than 50 and A is less than 100. Okay, what happened to this? Mm, A is greater than 50 and A is less than 100 we have written. T1 and T2, T1 is equal to new, T2 is equal to new. T1 dot constraint. Okay, okay. I'm basically displaying T1 handle. So T1, the constraint is off now. That's why it's showing like that. Let me randomize, and I'm randomizing T2 dot randomize now. Okay, yeah. So it's not affecting my T2 constraint. Okay, so T2 is working. What is the T2 condition we have? A is less than 100. That is working fine. Only. Is it clear, guys? Okay. Is it clear? This one is it clear? Yes. Okay. So that is how you're going to work with your constraint underscore mode and rand underscore mode. So yes, yes, I will show you. So basically, if you're going to use rand underscore mode, it is going to enable or disable your randomization, and whereas your constraint underscore mode is going to enable or disable your constraint underscore mode. Now, tell me what is your queries. Now, someone is asking, right? So, what is your soft way to use the soft keyword in the parent class? You're asking. So basically, the soft keyword is used where when we feel that there is some type of conflicting. So we have seen in our yesterday session, right? So there is no conflict over here. If we use soft keyword and if we don't use the soft keyword also, anything will be same only. So let me show you. Okay. So soft keyword comes in. Yeah, I've told, right. If we are going to use a soft keyword in both the things, it's selecting the value of a to be 0. So I need to once check it out why it is giving so. But here it is not giving that particular value. It is following the second one. If we are going to use a soft keyword in the second one, it is basically following the normal constraint only. It is following the second constraint. Okay, is it clear? Yeah. So shall we move forward? Any other queries? Okay. So let us start with a particular topic which is known as set membership. Okay. So let us see what do you mean by set membership. First, let's see the syntax of how your set membership is going to look like. Okay. So basically your set membership, the syntax for your set membership is going to look like this. You're going to write down your constraint and followed by the constraint name. Let's say some data underscore range is my constraint name which I'm going to have. And here I'm going to write it down the variable, and I'm going to use a keyword which is known as inside. So if I'm going to use a keyword which is known as inside, this will come under the concept of set membership. Okay, inside I'm going to write down, let's say the values, let's say 1, 3, 5. These are the values which I'm going to have, and followed by curly braces and followed by again curly braces. So what do I mean by this? So whatever the variable I'm going to have, that variable should have the values of 1, 3, and 5. That's it. That is nothing but my set membership. So using this set membership, using this inside keyword, what I can do is I can basically decide what particular random values this particular variable should have. Okay. So using the set membership, I'm going to decide. Let me show you how it is going to work. So let me remove this things. So here what I'm going to write down is the variable a inside I'm going to use, and let's say the variable should have 1, 5, 6. These are the values this particular variable should have. Okay. Now let us check what is that we are going to have. I'm repeating this particular randomization for 4 number of times, and let's say this is test t1, and let me run it one more time. See, I'm getting 1, 5, 6, 1. Only the values which I have given in this particular list, only that particular values are being generated whenever I'm randomizing it. Okay. So it may be for any number of times. If I'm going to randomize it, only those particular values will be randomized and given to me. Can we add for loop and for each loop? Yes, we can add. I will show you. The set membership will be useful for corner cases. Yes, exactly. In the functional verification, we are going to use this set membership for checking out our corner test cases and all. Okay. So for that, we are basically building the foundation for that. Okay. Okay. Is it clear? This concept of set membership, is it clear? And in this particular set membership, we can also give the range of values. For example, this is my example number one, which I'm going to have. And let's say if I'm going to have one more example, I can simply write down constraint, and let's say data underscore range underscore 2. I can simply write it down variable inside. I can simply write a range of values I can give from 0 to 5. So from 0 to 5, this particular values will be given to this variable. Okay. So let's see how to use it. So instead of giving the individual values, I can give the range of set of values. So what I can do is from 50 to 100. I can give like this. These are the range of values which I can give, and repeat of 10. Yes, you can have. Not exactly. Let me show you. So if we are going here, it is not going to follow the order. It is going to basically follow the values. Okay. Now, if you want to print the pattern like 135, it is not going to follow the order. If you're going to give 135 over here, it is not going to exactly follow the order. But this is going to make sure that the values which you have declared over here in the set membership, that values are to be randomized. Okay. So 156 will be present whenever your variable is being randomized, or else the values between 50 to 100 will be displayed. Is it clear? So this is how you can either mention the range of values, or else you can also mention the individual values which you need. This is how your set membership is going to have. Not RANC also. RANC also cannot basically confirm you that you are going to have the pattern of 135 like that. Okay. The order we are not going to get like this. So for solving the pattern related questions, I will show you like when we are going to discuss about the problems. Okay. Yeah. Is it clear, guys? Any doubts or any queries in this? Okay, that's great. Now, now let's say if I have if I have a particular requirement. What is the requirement over here is, let's say if I have a variable a, and for this variable a, the value 5 should be repeated for 10 number of times, and the value 10 should be repeated for 5 number of times. This is the type of requirement. what are this type of requirements, what is the set membership, where we are going to use that, and all we will discuss when we are going to discuss about the test bench development and the test bench driving and functional verification, functional coverage. Those there these are basically used. Okay. Yeah. So let's say if I have this particular requirement of A generating for 5 times and 10 being generated for 5 times and 5 generated for 10 times. This is my requirement I'm going to have. So what I'm going to do is constraint. I'm going to write down. Let's say the constraint name is range underscore data. And here I'm going to use a curly braces, and whatever the variable A is my variable, here I'm going to use a keyword which is known as dist. Okay. So this will come under distributed constraints. So if you want to give the weights, these are nothing but weight. This is known as your weight. So 10 number of times, 5 number of times, if you have the requirement, right? This is nothing but my weight. Okay. And a dist, and here I'm going to provide the weight. So I'm going to use a keyword which is known as colon equal to I'm going to use. And here what I'm going to write down. So a should be repeated. Uh, so I need to write down within a curly braces. So 5 should be repeated for how many times? It should be repeated for 10 number of times. Next, 10 should be repeated for 5 times. This is what the weight of 5 and 10 I have given, and followed by semicolon. That's it. Okay. So let's check it out how it is going to work. So this is how I'm going to write down a variable a dist keyword and curly braces. 5 should be repeated for 10 times. 10 should be repeated for 5 times. This is what I'm going to write it down. Okay. So let me write it down over here. So 1 should be repeated for 5 times and 2 should be repeated for 10 times. This is my requirement which I'm going to have. Okay. And here I'm going to use a keyword which is known as dist. Okay. And let me repeat the process for 50 number of times. See, so it will basically follow that particular weight which we are going to have, and it is going to make sure that 1 is repeated for 5 times. Is it repeating? 1, 2, 3, 4, 5. And it can also repeat it for more than 5 times. It's not like that one should be only repeated for 5 times, but it we can get the repetition more than 5 times also, but minimum it will maintain one to be repeated for 5 times and to be repeated for 10 times, and still we are running it for 50 times, right? So it might get more than that. So let's say we are repeating it for 15 times, and let's check it out. What is it we are going to get? So 1, 2, 3, 4. So 1 is repeating for 4 number of times, and 2 is being repeated for how many times? 11 number of times. Okay. So whatever the condition you have given, it might be true and it might not be true. So see here. So 1 is repeating for 1, 2, 3, 4 times only, and 2 is repeating for 11 times. Okay. So it's completely random and it might work or it might not be work. We cannot make sure that. Okay. Yes. So this is nothing but my distributed constraints. Is it clear? 2 has more weight. Yeah, exactly. 2 has more weight, so it can happen. Okay. Yes. So that's about our distributed constraints and set membership. And from our next session, we are going to see about problems related to